then we're coming to the part that everybody came for. Our first speaker is Martine Dowden. She is a UI UX designer and developer author. She speaks internationally. She focuses specifically on UX and accessibility. She is writing a book that will be out in December, but I'm going to turn the time over to you.
So we're going to talk about unit testing, specifically in the context of reactive forms. And so I know when I first started doing unit testing, right, like it was interesting. I didn't really know where to start. I didn't really know what sort of things I really wanted to consider in terms of like, what should I test? What shouldn't I test? And so one of the things I started doing was going, okay, what are the requirements that I was given for this piece of code that I'm going to be writing, right? And so what are, based on that, those are probably where I should start with my testing. And obviously some things are pretty, like if there's an area we know that is going to be prone to bugs, or an area that we know is particularly complex, those are always good candidates. But for forms, there's so many aspects to it that I was like, well, where do I start? And so I started looking at, okay, what was I given as my requirements? And from there, writing unit tests based on those requirements. So if we go for a very, very simple contact form, like obviously these requirements are not fully fleshed out. I kind of narrowed them down in order to be able to talk to them more and talk about them more easily and more succinctly. But basically we have a form, we have 4 fields in the form: a name, email, phone number, message. Obviously email should only allow for actual email addresses. We have some max lengths that we want to consider. Now, notice I put email, I put a max length of 25, and that's so that I could use, put the code samples in a slide deck and not have to have strings that are ridiculously long in order to do an email address. More than likely, you'll want it to be longer than that. But, our message, we want to be able to show, what our message count is. Obviously, if there's an error in the field, we want to show the error. And then we have 2 buttons, a send and a reset. So basically, we end up with something that kind of looks like this. I used Angular, in just standard HTML, CSS. I did not use Angular material for this on purpose because I wanted to kind of focus on how would you unit test the form in and of itself without throwing in the concept of material into the mix, especially in that, half an hour talk. So from there, and we would either write the test first, either write the code first. It doesn't really matter in this particular use case because we're mostly going to focus on the, on the actual test piece itself. So we end up writing some type of form. In the reactive, if we write the reactive form, we end up with a group that has a name, email, phone number, and message. I'm using Form Builder in this case because it makes things a whole lot easier. Hence the underscore FB. That's going to be your form builder. And we add the validators, right? We're going to add our required, we're going to add our max length, and for email, we're going to add a pattern, into which we're going to pass some random set of characters that we otherwise know as regex, right? And so from there, now I have to say, okay, does my form actually validate like it's supposed to? And does my form actually do what it's supposed to? So we can I'm going to look at email specifically because email has kind of the most going on, right? It's got a regex we definitely want to test. And then it's got the same kind of other 2 validators that the other fields have. Now, and so most of the tests we would write for email, we're going to be wanting to write for the other fields as well. So I'm going to focus mainly on this one because it's got the most going on. So when we look at the structure of a unit test in Angular, we're going to have several parts, right? We're going to have the some string, right? And that string is going to be descriptive of what is it that the test is actually testing. That's usually where I'm going to basically copy paste, unless it's, a diatribe. I'm going to copy paste whatever the acceptance criteria is. I'm going to put the what it should do. And then we have kind of whatever setup we need for a scenario. And then we have that expected output. We may or may not want to trigger change detection because in the test, unless we tell it to detect changes, it's not going to. So if we change, so for example, in this scenario I'm showing, I'm saying, I want you to go and get from the component, I want to get the form, and in that form, I want to find the email, right? Because and in that email, I want to patch a value. It's not going to trigger change detection on its own. So once I patch my value, it's not going to recalculate all of the things. I need to actually go ahead and forcibly do that change detection. And then I can go ahead and say, is it going to be valid, yes or no? So in this case, since our email is required, if I patch a value of null, I would expect the email valid to come back as false, correct? So very simple, straight to the point kind of test. I can then kind of take that structure and kind of repeat it. So if I want to look at, I'm going to check the validity. Obviously, the word user is not a valid email address. So I can go ahead and say, okay, same thing. I've got my acceptance criteria. I've got, or the it that describes it. I've got my scenario, my trigger change detection, and my output. Same idea. I'm going to pass it a value of email, which is obviously of user, which is obviously invalid because it doesn't have the at whatever dot whatever, right? I'm going to trigger my change detection. Excuse me. And I'm going to expect it to return false because that means that my pattern, that regex I put in, is actually working. Now, we're going to be doing this a lot, right? Because we can test multiple aspects of it. So in this particular, and we still have this first one, which is this piece right here, is the same that we had before. So it's where we check just passing in user, we expect it to be false. We can patch in an actual email address that should pass and say it to be true. So we're going to be doing, and we can put multiple expects inside of a single test. So if you wanted to basically check something like a process from A to Z, or a chain of events, for example, or a chain of calculations, you could totally go for, your first piece, do an expect to check that it's correct, do your next piece, expect that it's correct, do a next piece, expect that it's correct, and check that it's correct at every step of the way. So it perfectly works, and it's just fine to put multiple expects inside of the test. At this point, though, essentially what I'm doing, whether it's the actual email address itself or whether it's there or not, I'm doing a whole lot of the same thing. I'm doing find the control, patch the value, detect the changes, check the validity. This is incredibly repetitive, and I don't want to write that test 50 bazillion times because it's going to end up being difficult to maintain, and it's just a lot of copy paste, and nobody likes to do that. So what we can do is, instead of the test, we can actually use standard JavaScript things, right? It's still that spec file that we're writing our test in is still just TypeScript. So we can absolutely say, here are a set of test cases, and I want you to run the same test for each of these test cases. So what happens with that is I'm going to give it a value, and I'm going to determine whether the value is true or false, right? I'm going to say, do I expect the output to be true or false? So the validity. And I'm going to go ahead and iterate over this with that same test, right? We find the control, we patch the value, we trigger change detection, and then we look to see if the value we got, or the validity we got, is supposed to be yes or no. So before I was using, if we go back one or two, I was using to be true or to be false, right? In this case, I'm just going to, oops, wrong direction. Ooh, lost my place. There we go. In this case, instead of to be true or to be false, I'm going to say to be, and I'm going to pass true or false, right? Because test that valid is coming from, this is our valid. So the first test, as it goes through, I'm going to say, I'm going to patch in, if we're going for this first one, we're going to patch null, our test value, and we're going to expect the email control to be invalid. Notice I have this little piece right here where I'm actually in the I actually put the test.value. And that's because since you're iterating over the test multiple times, if we have just one string there without any parameter telling us which one in the array goes through. If one of them happens to fail, debugging becomes a little bit of a pain because you don't know which one of the loop, right, failed. Now, for email addresses specifically, there's actually like a formal list of email validation considerations at datatracker.ietf.org, which gives you all of the options that you should be checking for your regex. Obviously, there's a huge number of them. I obviously did not put all of them on this slide. But this would allow us to, in one fell swoop, check the required, right? Because null or undefined should return false, and that it should only accept valid email addresses, because we're going to plug in some valid ones and check that they work. And we're going to plug some invalid ones and check that they don't work. Any questions so far? I don't know if I can see the chat. Where's the chat?
We did have one question. Should we say that to the end, or?
Yeah. No, go ahead
okay.
and because it gets complex really quickly. So I'd rather take the questions as they come.
Sure. So Oscar asked, reactive forms code can become very big very quickly. What would you consider a reactive form to be testable?
The advantage of reactive forms is that in the test, right, we can always hit component dot, right? So in the if you pick when you spin up a new component, if you just take the default, if you look at the default setup for the test, that component allows you to hit any property that's inside of the component. And so our form, which I've very skillfully named form, you can hit that from the test. So at that point, you have access to any of the properties within that form, which are a lot easier to get to than, say, a template-driven form where you don't have the validity and all that fun stuff kind of driven in quite as neatly as you would with a reactive form. So I find that it's not necessarily of which reactive form is testable as much as it's I tend to find reactive forms easier to test than template-driven forms. Somebody with that, somebody else may have a different opinion on which is easier. That's just where I find that, because you have that nice object that you can deal with, that form group to deal with, I just find them a lot easier to test for. In terms of their complexity, I mean, the complexity you see in the form is going to end up more or less reflecting itself in the complexity and the number of tests that you need to write, essentially. Does that help answer the question?
It does for me. I don't see any other questions in our Q&A section.
Yeah, but I'm not seeing the chat because I have it full screen, so don't hesitate to interrupt me.
Okay.
Thank you. All right, so we have our email and the fact that it's required and the validity handled. So let's check our next piece. The next piece is that we want to make sure that the maximum length of our email address is no longer than 25 characters long. So we can continue that in the array in the test that we've already constructed, right? We can go ahead and say, I'm going to pass this stupid long value. But the thing is we want to make sure that it's still a valid email address per our regex, because at that point, you're simply testing the validity, not the length, right? So you got to make sure that you're testing one aspect of it at a time. So in this case, we're going to put this, a ridiculously long email address that would actually pass our regex and still say it's going to be false. And so we can check for length as well. And generally for length, what I end up doing is I check, if I say that we have a max length of 25, I will do a 24, which I would expect to pass, a 25, what I would expect to fail, and a 26, which I would expect to fail. All right, that way you have like that. I mean, the 24 and 25 should pass, 26 should fail. I pick one on each side and then the one that's the mark. That way I can make sure that the cutover is happening at the correct spot, if that makes sense. So we have the email, we have our validity, we have our required, and we have our max length. We still need to look at our errors. and whether it's visible on the screen, because at this point we've validated that the control and the amounts of info and like the validators that we've passed to our control work, but we haven't validated that the control actually shows up on the screen. So in the way I've written the HTML for this form, I have a label inside of which we have a span, inside of which has the whether or not it's required, a little star, pretty standard convention, and then the word email, and then the label, as well as the input and a div that allows us to, via a function in our controller, show us our errors. So the first thing we're going to do is make sure that the form or the form field actually shows up on the screen. So to do that, we're going to use query selector. So to get to query selector and to being able to use standard DOM manipulation, we're going to use fixture debug element, native element. This gets us to the root of our component and of the HTML and allows us to use standard DOM manipulation to go query for things, to go look for things, to go click on things, to go simulate events, whatever the case might be. At that point, once you found that element, once you're there, you can use anything you would use for standard DOM manipulation and crawl the DOM tree, the whole thing like you would for that component. So in this case, I'm using query selector. And so query selector is going to allow me to select any element using the same kind of queries you would use in CSS, right? So in this case, I'm saying I want you to find an input that has an attribute of form control name of email. So we can say that here's my input, and it's going to have a form control name of email. Query selector is, if I had two of these on the screen, it would find the first one and stop, and that's what it would return. So in this case, it's going to find the first element in my component that matches this query. And so I'm going to say, go find the element, and I'm going to expect that to be truthy. That's the big advantage of being in TypeScript or JavaScript, is that in this case, I don't have to try to figure out what that return is going to be. I'm just going to say I wanted to know that it exists. So I want it to be truthy, not necessarily it's not going to be true, right? Because that's going to return me the actual element. So in this case, I want it to be truthy. And if I expected it to not be there, I could expect it to be falsy, right? So at this point, I've found my element and I've validated that, hey, it's there, it's on the screen. And so now I can start handling our error messages. So I'm going to continue within this test. More than likely, if I were to write it like in the wild, I would keep this as its individual, as an individual test, and then the whether or not it displays on the screen, and then go on to make a different test for the errors. But I went ahead and grouped them here because we already have this piece and we would still have to query for that element. So, so that's kind of the idea. So at this point, and we're going to break this up and go through this chunk by chunk because there's a lot in this test. But essentially what we're going to do at a high level is we're going to find our input element. We're going to go ahead and through our control mechanism, patch a value. And then we're going to check that if based on the invalid value that we're displaying the error message that we expect to on the screen. So let's break that down a little bit and see how that maps up to our code and why this code actually performs what I'm saying it does. So the first piece, this part that's grayed out, we already talked about, right? We're finding the element, we're expecting it to be truthy. We're good to go. We know the element's on the screen. Now we're going to patch the value. We get the control of email because we're still dealing with email. We patch a value of not a valid email, which is just definitely not a valid email, but it is less than 25, right? It is less than 25 characters long, and this is going to matter in just a second. Then I mark it as touched. And the reason I mark it as touched is because in my show error function, which is here, what I'm doing is essentially I'm passing in a form control name. You can see in my HTML over here, I say, show errors my email. So I pass my form control name. I'm going to go find that form control. If the control doesn't exist because I typoed it or something, or if it doesn't have errors I'm returning, I'm fine. There's no errors to be had. But if there is, I'm going to take the keys of the errors that the input returns and go find based on an object I have in the JavaScript, the error to return. So because I'm only showing the error once the control has been touched, because I don't know about you, but when you open a form and it's yelling at you with errors before you've even touched it, that's not very nice. So that's why we're going to go ahead and make sure that we're only showing the error once it's touched. So because of that, I have to make sure to simulate the fact that it has in fact been touched. And then we can detect the changes, right? Because again, if we want, and we do this at this particular point in time because by being touched and having a value, that's what's going to trigger the error to show up. So this fixture detect changes is going to be what triggers the error to show up. So now we're going to, with this part, which is basically our scenario setup, which is making sure that they show up, we can go find the error and go ahead and make sure that it's displaying the error we want it to be displaying. So in order to do that, I'm going to go find, we already found in the email input by looking for control name email. Because I've nested the input inside of the label, I can go ahead and say, I can go ahead and find the parent node of my input. So the parent node of my input is label. And because I already have this query selector returns an element. Now, in terms of your JavaScript or your TypeScript, I mean, it's not going to know the typing. It's going to return, I think it returns an any, if I'm not mistaken. So you'll have to type it in order to get your, autocomplete and those sorts of things. But so from there, I know that I have I'm going to make sure I know that I have my label. I'm going to find the parent. Actually, this is incorrect. That should be in, yeah, the email input that parent node does return that. Yeah, we're good. And so that's going to be my container. And so inside of the container, then I can do a query selector all of errors because I want to find all of the divs because this is an NG4, right? It has a repeater. So if we have 2 errors, so say it's not only not a valid email address, but more than 25 characters long, I would have more than 1 error, right? I have one for the fact that the pattern is incorrect and one for the fact that the max length is incorrect or invalid. So I'm going to find query selector all. So the difference between query selector and query selector all is query selector gets the first one it finds and stops. Query selector all returns a node list. So node list in a lot of ways functions similarly to an array. So I can totally find the length and find, and get based on index, I can find elements based on index. So at this point, we've found our parent and we've found our errors. Now we can go ahead and check what errors are being displayed. So to check what errors are being displayed, like I said, our show errors is going to return an array of errors to an array of strings to be able to display on the screen, right? Because if the input is invalid, we go ahead and get the error name -key, which we have this nice little object that returns standard errors. So I don't have to write the errors 50 times. And there we go, we can NG4. So at this point, what we're doing is we're checking that because the input that we passed in is an invalid email, but not longer than 25 characters. So the 25 characters would pass, that wouldn't throw an error. The fact that it's required would pass, that wouldn't throw an error. The only error that we're going to throw is pattern. So we should only have 1 error. So I'm going to expect my error.length to equal to 1. And then I'm going to expect my first error to be equal to my component error pattern, right? Because it's a pattern-based error. So I'm going to make sure that that's what shows up. And so from there, altogether, we find the input, we check that it's visible, we patch a value, we mark it as touched, we trigger the change detection, patch the input, marking it as whatever the case might be if we need to, and then triggering change detection is kind of the crux of almost every test related to reactive forms. You're going to be doing this a lot. Then we find the input container, which is our label. We make sure that we find all of the diffs with errors, and then we can check the number of visibles and the content of said errors based on whatever value we passed in to the email address. Now we're not quite done yet because we've checked 1 of the 3 possible errors we can have. We've checked the fact that right now the fact that the pattern error is showing, but not the other 2. So in order to do that, we can go back to our trusty array, right? We're going to do the same trick we did before, and we're going to parameterize. We're going to add a parameter to the name for debugging purposes. We're going to go ahead and change the patch value to our, iteration value, and same with our error. And then we can go ahead and parameterize all that to get our email, our test to run for. And now we could basically take this chunk and essentially this concept and repeat it for each of our different element, and already have a pretty good sense that we're matching a large chunk of our requirements. Any questions at this point? Cool.
We do have one question.
Okay.
What is the difference between it and fit in the test methods?
Oh, fit and it. Okay, so fit and is a really cool little thing. If you add an F in front of the describe or the it, what it'll do is it'll tell when you're doing ng test, it'll go ahead and run just that test. So if you put fit, instead of running every single test, it'll just run that one, which is kind of cool when you're especially if you have a really big test suite. If you're wanting to hone in on that one test that's being a pain in the butt and not want to rerun every last bloody test every time you make a change, you can add an F in front of the it in order to be able to make it run just that one test. And that's probably me copying and pasting and forgetting it when I was making sure that the test ran, that the code I was presenting to you guys actually runs.
Oh, great, thank you.
You can also actually put an F in front of in front of a describe. So at the beginning of inside of the spec file, right, you have the describe. And so if you put an F in front of the describe, what it'll do is it'll run only what's in that file instead of running all of the spec files. So that's a way to easily narrow down which tests you're running. But don't forget to take it out once you're done. Otherwise, if you have that in your CI or something like that, then it's only going to run like one of your tests instead of your entire test suite. And yeah, that's not good. Anything else?
Nope, that's the only questions we have.
Cool. So let's recap. So when you're going about testing, start with the requirement. If you don't know where to start with the requirements and see based on the requirements you're given or the business requirements, what are the best things that are going to be, what are the most important things for me to write tests against? And obviously the second one is something brittle or likely to break or likely to cause errors? That's always a good one as well. All tests must have an expect, right? You have to tell it what the behavior that comes out of whatever scenario you put in there is going to be. You can reference anything in your component that is public using, component or whatever you decide to name it. But if you're using the default, if you're creating your components using the CRLI, it's going to be component. You use fixture.detect changes to trigger change detection, and you're going to need to do that. So if you're saying, well, if I'm doing this by hand, it works great. So why does my test not do it? And is saying that this thing doesn't exist or this thing isn't happening, make sure you've got your fixture.detect changes where they're supposed to be. You can use arrays to loop through scenarios and test cases, which is really handy in not having to rewrite the same code over and over and over and over again. And then fixture.debug element gives you access to the DOM. And so then you can use your standard DOM manipulations like query selector and query selector all to find elements, to determine if they're there, to manipulate them, to do whatever. That's a great way also to do a simulated click. Like you can go find your button and click it, for example. So those are really helpful in being able, when you're manipulating outside of simply, patching values and checking validity based on that. You can find the code that I just presented on Angular on GitHub. The project name is Angular Unit Testing. And so it's the component name that specifically has the code I presented today is HTML-forms. Forms. So feel free to check that out. And I could put links in the chat here in a second. And then I also wrote a blog post that shows a lot and a little bit more of what I presented today. So feel free to check that out. It's on my blog at andromedagalactic.com. And with that, thank you very, very much. And I will take any other questions you may have. And if you can't think of it now, and you could, of course, once the meetup is over and you have one later, feel free to hit me up on Twitter. My DMs are open, so feel free to talk to me at any time.
We did
There
have.
was-
Well, go
I was going
ahead.
to say there is Yusuf has put up a question there. And what would be the best approach to unit test complex forms that include multiple form groups and or form arrays?
Usually what I will do with that, I will kind of think of it like if it's multiple groups, I will usually kind of deal with each group individually and then deal with the interaction between the groups. So maybe I will write a set of unit tests. So can I share code? I can share code, right? Yes. This should do oh, I have to stop share and share differently. Okay. How do I share my Visual Studio code? Here we go, I think. This one. Share. Okay. So if we look at a standard, why can you not let me move it? Oh. Okay, if we look at a standard piece of a standard test component, right? Over here, what we have is we have this describe. Where's the describe? This describe. We can actually nest describes. So a lot of time what I'll do is I'll go ahead and put a describe at this level, because you can totally say describe my subgroup, whatever it might be. And then hyper focus on that subgroup, which also when you have a test that runs inside of a subdescribe like that, what happens is it also in the printout will actually go ahead and nicely categorize them and group them for you as well. So it's a nice way to organize it. And then you can always collapse them, which is nice. So when you end up with 50 different things, right, it also allows you to organize your code. But I would attack it from here's that subgroup I'm dealing with. Here's that subgroup I'm dealing with. Maybe here's that form array I'm dealing with. And then maybe lastly, how each piece interact with each other. But I would break it down into the big picture in small pieces rather than trying to attack it. This one, I picked the hardest one in the lot so that I could show the most diverse things. But generally, I'm going to go top to bottom in my form, hitting up one group at a time or one value at a time until I hit a group and then maybe hit that group or something and then keep going and then kind of narrow in as I go into each group. Now, other people may have different strategies. That's just the way I go about it. And it's more about at that point, code organization and making sure I don't miss something than it is anything else.
I love unit testing, but I have a more serious question. What's your favorite VS Code theme and font?
So my current one is, I don't bloody know. This is my favorite one right here. So let's find out, what is it? It is called One Monokai Italic. And nice. The code is, I edited the style so that I could have italics, and I think the actual typeface is Fira code. I think. Don't quote me on that.
Thank you. It looks good. I like it. It's a clean look.
We did just have one other question come in. How would you approach form validation that involves backend HTTP calls? Would you handle that differently?
Well, it's a unit test. So because at that point, I'm going to mock, in my unit test, I mock my services. And so because at that point you're dealing with an HTTP call, you're no longer segregating to that. So I would mock the HTTP call. And so because at that point you're not talking about integration test and no longer unit test, right? So the point of the unit test would be does the form do what I would expect if the validation comes out as true or false from the HTTP call, but that actual what you send the HTTP call and coming back in that whole loop, at that point is no longer a unit test, it's an integration test.
Right. Next up, we have Doguhan. So we've actually got 3 authors, right? We've got Deborah, who's published, we've got Doguhan, and we've got Martine, all 3 authors.
Rare company to be in.
Yeah, we're excited to hear from you. Turn the time over to you.
Okay. Can you all see my screen?
Yes. Yep.
Okie doke. Thank you so much. All right. Well, welcome everybody. Today I'd like to talk about 5 ways to make sure your Angular code is agile. My name is Doguhan Uluca, and I'm a principal fellow at Excella. All right. So, what is it? What does it mean to be agile? You know, when you think of the word agile, do you instantly think about one of these things? You know, these are agile frameworks. They're not agile. They're certainly not being agile. Is not part of that. So to truly understand what being agile means, we have to go back to the source, agilemanifesto.org, and within there's a list of 12 principles of agile software. So I picked a few of these, and I'd like to go over them real quick. Our highest priority is early and continuous delivery of valuable software. We need to be able to adapt to changing requirements even late in development. We need to be delivering working software frequently. And our primary measure of progress is working software, not points, not, you know, other things. It's working software. We need to promote sustainable development because it's a marathon. It's not a sprint. And we need to have continuous attention to technical excellence, because if we don't do that, we're not going to be able to achieve most of these things. But and my favorite principle is simplicity. The art of maximizing the amount of work not done is essential. So these principles are directed at you, the developers. So we're not really looking to be agile, but we're looking at agility. We're looking at consistent forward flow of features. So we need to build that pipeline that allows us to deliver that value continuously. And at the end of the day, it's not up to them, you know, the managers, the clients, customers, or anybody else, but it's up to us, the developers, to get it done. It's up to you to deliver a quality product. So what are 5 ways that can help you make sure your Angular code is agile? First, we need to be relentlessly iterative and incremental in our development. Second, our code needs to be open to extension and closed to modification. Third, pick a component library and stick to it. Fourth, test smart. And 5, think twice, nay thrice, and code less. And yes, that is a serious suggestion. All right, so let's dive in. What it means to develop iteratively and incrementally. We're going to look into this login experience. This is a very simplistic example, but it highlights the process a little bit. So, you know, our designers go, or we just, you know, scribble something on a piece of paper. We come up with a design for login experience. So our first implementation of this should be as simple as possible. An example of this is just simply a screen with a login button. You know, you don't need to worry about capturing emails, usernames, passwords, or the various error conditions, things like that. You just need to be able to put something out there and you know, get the work started. And then later on, you can iterate on this page, you know, flesh out the design, you know, make the buttons actually work, the validations, all that stuff, and get it working. And you know, this is achieved iteratively and incrementally. At every step, you are delivering something, some value. You're pushing the boundaries, and then later on, you're able to iterate on your initial work. So another example of this is forms. Once again, this is an example with only a few fields, but we've all worked with forms that can grow to 60 plus fields sometimes. So some forms are multi-step and they have hundreds of input fields. So not doing this correctly can send you down a rabbit hole where you spend most of your time just working on the first 30 fields for the next 6 months. So first start with a read-only preview type of representation of your form. This will help you get over your integration woes early on. You get your bindings working, make sure you're able to pull data from the server, and then later on, just do a simple layout. Don't just make using a text input box for text and date input box for date. Don't worry about too much of the details. Nothing fancy. No validation. Nothing. Just have that be your second pass. It's really important to get this stuff done quickly because you're pushing this in front of your testers, your product managers, your clients, and they're able to get a sense of what's going to come. So we're doing a lot of expectation setting here as well, because we can only improve things from there. And then second, then worry about your layout. Have a responsive layout, so things are more pleasing and they fit the use case more appropriately. For example, if you're working on back office applications, you want a more dense look to fit in as more input fields, usually because you're working with pros who know what they're doing. If you're consumer products, you want things a little bit more spaced out usually. And then continue iterating, add your validations, fancy and customized user controls and all that stuff, and really, fulfill the requirements that were set forth initially. But doing this iteratively and incrementally is a core tenet of or a demonstration of agility. Another example here is we can have a form which can take phone numbers, but just in your initial pass, just make it a single phone number, with simple inputs, and then on your second pass, make sure you add the type ahead functionality, and then on your third pass, add your validations and make your phone numbers dynamic so you can capture multiple types. So once again, achieved iteratively and incrementally. The other way of achieving iterative and incremental development is through reactive coding practices. This reactive coding allows your code to be composable and stateless. So here we have a GET request for products, and we only have to code this once. We can then build a pipeline on this and tap the data, log it. We can handle errors. Now we can cache our response. But most importantly, the products property at the very beginning here, we can reuse that later on. So if we look at this example where we have products with categories, here we can reuse that product's observable that we created earlier. We can combine that with a product categories observable we developed elsewhere. And then in this new pipeline, we can synchronize their responses and then match the correct category to the product, so we can take that and display it on our user interface. And of course, then we can cache the results of this as well. So by writing more reactive code, we are able to once again develop iteratively and incrementally, because we don't have to keep rewriting code. We can add to it. We can compose, and our code being stateless makes it possible to do this mix and match. All right. So number 2 is writing code that's open to extension and close to modification. So The open-close principle is part of the larger solid principles, but it's a pretty important one. And it is supported by really the rest of the principles as well. So here, think of once again an authentication scenario. We're gonna see how we can build an authentication service that leverages these principles. It's open to modification, or it's open to extension but closed to modification, and we'll see what that means. So here we have an authentication service which extends a cache service. So we're leveraging inheritance here to reuse some behavior. We also implement an interface that shows what our authentication service can do, but not how. And using interfaces across your application in this manner really helps also you develop more iteratively and incrementally as well. So this authentication service is going to have a couple of properties, 3 functions, and then 3 abstract functions, and we'll see what those do. And then the plan is going to be to take this authentication service and then implement 3 specific authentication services. So one is going to be an in-memory service to help with testing, etc. The other one is going to be a Firebase service, and then the third one is going to be a custom one that can just talk to our own server. So here we have the interface, which defines what our service can do. So it has an authentication status, a current user, properties, and then it can log in using an email and a password, log out, and then you can extract the JWT token out of it as well. So if we look at the abstract class, by the way, abstract means you cannot actually new up an authentication service, so you can't have an instance of it. However, it can contain some base behavior. So when we first created, we have our 2 properties, an empty constructor, and then 3 stubs for the login, logout, and get token functionality. So we'll visit those later here. And then we define our abstract functions here, and this means these functions also cannot be implemented within the authentication service. However, if we inherit from auth service, then the inheritor has to implement those. So if I create an in-memory or Firebase auth service, I have to implement these 3 functions. So, and those are auth provider, transform JWT token, and get current user. So we're just going to look at the details of the login function here. So login function uses the clear token function from before, and then it uses the abstract auth provider. So when we're implementing this login function, we have no idea the implementation details behind the auth provider, and this actually fulfills the list-go substitution principle. And this means the implementer of the auth service can actually define its custom value. However, I can orchestrate the usage of the auth provider, the set token, and then the transform JWT token functions within this login logic. So the user of this login function, or the implementer of the specific authentication server, does not have to change anything within this login function, because it encapsulates all the behavior, all the mechanics of how a login should work and in which order these functions should be called. And then, so for example, if we look at an in-memory auth service here, we see that it implements its own auth provider, its own transform JWT token, and get current user. function. And then same with a Fire-based auth service. It actually leverages the Angular Fire auth library here. And within its constructor, you can see it's calling super, which is the constructor of the abstract service. And then it implements its own auth provider, transform JDB token, and get current user functions. And in this particular case, it also overrides the behavior of the base logout method. And then same goes for a custom authentication service, where it just basically calls our own server to do the login. So by doing this, we have created a scenario where we can bake in a lot of the core logic into an abstract service that doesn't need to be touched by anyone. However, it's open to extension via the way of inheritance, and we can use these different authentication methods in a factory setting. In our app.module, we can create providers, and then we can tell it to use the authentication factory, which in this case just uses an environment variable to determine what the authentication mode is, and then based on that, it can in real time provide the implementation that's desired. So if you leverage solid principles to write your code, you'll be able to write code that is open to extension and close to modification, and this helps your code base remain agile. All right. Third topic is pick a component library and stick to it. The picking part is easy usually, but sticking to it part is the more difficult part. So step one, pick a component library, like Bootstrap. No, that's just a trick. Bootstrap is not a component library. It is a UI. I guess it's a UI library. So what's a component library, or some examples of component libraries? We have Angular Material, we have Kendo Ui for Angular, there's Prime NG. If you have other examples, please feel free to share it in the chat. But so, what does a component library do? In Angular components, we have a combination of our JavaScript class and our Angular template. Our JavaScript class uses TypeScript. Our Angular template uses HTML and CSS. And of course, the magic comes from this Angular binding that forms an Angular component. So, for example, when you use a library like Bootstrap, it kind of only provides you a sliver of the functionality you need, whereas a full component library gives you the whole deal. All right, and step two, stick to it. This is really important. Do not go around Googling your way through it, because your product managers, your clients, they're gonna send you examples, links to GitHub projects. Oh, look, it's so easy. I just Googled, some date picker that I love. Here's the GitHub project, here's the npm link. Go. Let's use this one. And then you're like, oh god, I got to get out of here. And then you just npm install, and then go with it. However, down the line, and this is not going to take too long, a few months down the line, if you add too many of these user controls to your project, you're quickly going to have a spiraling mess of npm dependencies that's going to be impossible to manage and maintain. And this is, I like to call it npm hell. So please don't do this unless you enjoy npm hell. All right, and are you rolling your own component library? You should first ask yourself, should you? Why are you doing this? And unless you're a massive company that has a dedicated department of just creating user components, I would mostly advise to stay away from it. because you ought to be knowing what you're doing, and it's a very specialized kind of web development to be developing components. But if you do, leverage the Angular Component Development Kit, establish a design system like Material Design or your own, test and stretch component individually, and have a robust automated pipeline that will test components individually and publish them. But also make sure within this pipeline that you're testing the components within the context of your application to make sure you're not breaking existing screens. This is much harder to do than just saying it here in a few bullet points. But overall, I'd say don't do it, because you'll feel like it's going to be this easy. You just got it. Everything's going in place. But soon, you're going to find out you're going to have to, do some amazing feats of engineering to make things work. And surely you're not going to be able to grow eight other arms to start coding your way through it. However, if you just use a component library, it'll be like laying bricks through one of these bricklaying robots. So pick a component library and stick to it, please. All right, number 4 is test smart. So we're all familiar with test-driven development. It allows you to it forces you to deeper thought about the design of your code. It ensures that you're writing testable code, and it avoids over-engineering. And in fact, someone said to write unit testable code, be sure to adhere to the single responsibility and open close principles of the solid principles, which we just covered earlier. So when writing tests, you should be following the first principle. Your tests should be fast, isolated, repeatable, self-verifying, and timely. The timely component is the most important. It's, for the most part, useless the unit test a piece of code you wrote 2 weeks ago, because the moment you move away from that specific task and onto the next story, you've forgot half the details of what you were doing anyhow. So keep your codes organized and focused. Focus on testing a single class or a single file or a single function at a time. And organizing your described statements in this manner is extremely helpful. So and also make sure in your unit tests file that your code is organized well. You should follow the arranged act assert method, which the arrange function of your unit test should be setting things up, the act part running the thing that you want to test, and assert verifying the results. I usually like to just insert comments to make it super clear what's doing what, because things can and do get very confusing very quickly. All right, that's the arrange, and that's the act, and that's the assert. All right, and isolating dependencies is also very important. So here we have a weather component that needs to talk to a weather service to get its data, which then needs to talk to an API. So we have our test harness around this test component, which allows us to create mocks for the services. So we don't have to actually go out to a service, and every time we can get the value that's expected out of it. And then we can also create spies to make sure that our mocked service is actually is following the correct procedure, and it is making an API call. And we can do that with inspection with the has been called assertion. So that's kind of how we can do all of that here. All right, and I will at the end of this share my slides so you can check out the code. So there's one issue though. So this is Mycone's testing permit. It tells us unit tests are fast and integration UI tests are slow. Also UI tests are costly and unit tests are cheap. However, in kind of front end testing with frameworks like Angular, we've just seen you're dealing with a mixture of HTML, CSS, and TypeScript code, that makes up a component with that Angular binding. So we need that test harness to make all the magic happen to us. So if you overuse unit tests in Angular, it actually pushes you kind of in the wrong direction. So for this, I recommend leveraging E2E testing like Cypress. And if you do so, you have to make sure you're mocking your REST endpoints so that your tests are repeatable and they're fast, so you're not waiting for some external dependency. And one of the challenges of leveraging multiple methods of testing is your ultimate test coverage results. So you need to make sure you merge those test coverage results. So if you, for example, if you're covering lines 1, 3, and 4 in this unit test, you have 38% code coverage. And then in your E2E tests, if you have covering 1, 6, 7, 8, you have 50%. However, there's an overlap here. So if we add these numbers together, your coverage is 88. Is it? Not really. So if you actually merge your coverage is at 75%. For this, test smart, merge your test coverage results. My colleague John Simon created a React TypeScript project that demonstrates how to do this, and this is applicable to Angular as well. There's the GitHub link. Please check it out. All right, and then finally, number 5, think twice and code less. So not all of us are Trinity. We're not going to be able to write crazy good code and hack a power plant in under 5 seconds. So for this, we need to stick to some principles. First is the dry principle. Don't repeat yourself. Don't repeat yourself. Don't repeat yourself. The second is the KISS principle. Keep it simple. The third is avoid complexity and depend on your own code. Just the other day I was watching a documentary about the pad left incident that happened 5 or 6 years ago, when half of the world has been depending on 11 lines of code to left pad a string, and this was an npm package, and then the developer pulled the code and everyone's pipeline started failing. So just implement this simple stuff in your own code base. It helps you control what you're working with. So there is a single responsibility principle, part of the solid principles. So it's very important to be strict with your code base about what your functions are responsible for. So in this case, we have a set rating function that is touching DOM elements, and it has business logic in it, and it's doing other things here, other things, and once again with the set display text. However, if we kind of refactor this and better name our functions, like separate our business logic and our functions that manipulate the DOM from each other, then we're better able to reuse the little code we have, and our implementation is more clear as a result. All right. So the other thing is, we're working with TypeScript. You can just write functions and export them and reuse them elsewhere. So definitely do that. Avoid just unnecessary libraries and avoid overusing dependency injection. Here's one example in Angular. You can write your own validators, for example, and then just group them in a file called validations.ts, and then you can just reuse these elsewhere in your code. And then once again, and this is an example of just clearly naming your properties and your functions. So it's just easy to grok, what your code is doing in one quick look. And then, if you're writing helper functions, like here, I have this find with pagination helper function that I wrote for myself. It just makes it possible to reuse logic, and it makes this get function here that much easier to read. Finally, use enums when you can. Please, no string literals in your code. So code is written once, read many times, and try to be as verbose as possible and create useful documentation, and no string literals, please. All right, readable, dry, and simple code. Write less code. And these are the 5 ways to make sure your Angular code is agile. Be iterative and incremental. Be open to extension and close to modification. Pick a component library and stick to it. Test smart. Think twice. Code less. You can check out my book Angular at angularforenterprise.com, my VS Code extension, angularevergreen.com. And thank you so much. Any questions?
Oh, thank you very much. That's really interesting, actually. There's a couple of, there was just about the point I was going to pick up on there was string literals in the enums. Are you saying not to use enums and use types?
I'm saying don't use string literals. Use enums.
Oh, okay.
Because enums convert string literals into enums or numbers, technically.
Yeah. So for maybe it's probably I'm sort of using sort of types for sort of strings in that sense, whereas I would have been using, say, enums for string literals in the past. I've tended to sort of move over to types now, so and use it and just especially when there's only sort of 3 or 4 strings there that you may have, sort of thing. We do have a few questions, actually. Lubus said, is it okay to combine UI libraries with component libraries, e.g. Tailwind CSS with Kendo UI?
I recommend against it. The reasons behind doing these things needs to be very strong, because usually such decisions are made hastily and in the heat of the moment. I feel like, and their downstream impact is just way too huge. Some of these decisions made early on in the project lifecycle can, render a project unmaintainable, 3-5 years down the road, and then you end up in a place where you have to rewrite or redo everything. We need to recognize, library builders like, Kendo or Angular Material. They're spending, hundreds or thousands or tens of thousands of engineering hours to make sure that their code works well in whole sorts of scenarios. And when you mix and match, 2 different things, you have no idea how they're gonna, what kind of side effects are going to get introduced. And then on top of that, God forbid your app becomes super popular, then you're going to need a lot of performance. And if you mix and match multiple tools, no one is going to be able to help you get out of your performance woes. But if you're just leaning on, Kendo, then opening up support tickets or buying a license, from a company like that is a lot cheaper than trying to get yourself out of a pickle of multiple overlapping libraries and code bases.
Sure. Yeah, okay. That's okay. Thanks for that. Hopefully that answers Lubus's question. Richie Rich has put a question up. Do you have any significantly do you have to have a significantly large app before you can apply these principles? What's your rule of thumb?
These core principles that I'm mentioning here, you should apply anywhere from your weekend, lazy weekend projects to your, giant, thousands of people enterprise projects. These are pretty, simple, suggestions to live by, and the especially the open close principle that I covered. It takes a lot of exercise to really get that get into that mindset, so some people do coding katas and all that stuff to practice these things, but if you always force yourself to write quality code with these the dry principle or the solid principles, you will always be practicing. So then it forces you to just, every time you write code, just write less code, but write quality code. And trust me, over time you'll get a lot faster as a result of it. So writing less code doesn't mean you're doing less work. Writing less code means actually you're able to go faster in the long run.
Okay, that answers. Yeah, so that makes sense. Yeah. So we lost. Serico, I think that is pronounced, as how to help management to understand the importance to create clean code, applying solid principles and tests. That's probably a difficult one.
No, I mean, this is something that we deal with quite a bit. I mean, I do IT consulting. We work with federal clients. We work with nonprofits and private companies, and it's always a process to communicate that we're building a building of a sort. So if we rush and shoddily build a few floors and then realize our our foundation is not enough to support another floor, then it's going to be very costly to replace that. So you have to make sure you're empathizing with the product people or management people, but one of the ways you can also empathize them by trust is this rapid iterative and incremental iteration process. So if they're seeing that they're getting things on a regular basis, then they're going to be far more likely to have that trust in you to allow you to do the necessary foundational work in your code base, so that you are delivering quality code. So you have to build that trust.
Sure. Okay. Danny's also put a question up there. Any advice about how to manage the inheritance problems in bigger Angular projects? For example, components inherited from other components.
So the problem with bigger is the moment you notice that there's too much of something, that practice needs to be stopped. And I know it sounds a little bit random to say that, but one of the ways, for example, you can detect that your unit testing wrong is if if your unit testing is so laborious, for example, you are clearly doing something wrong. We're not saying anything is easy. I don't ever use that word, but it also should never be like really hard. That means you need to, because every situation, every app, every company, every engineering teams grows in different ways, and they stress different parts of their development process differently. So this answer depends on your specific situation. But if you're noticing so much of something is going on, then you just need to come up with rules to stop that practice. So yeah, there's an appropriate amount of inheritance you should be doing, but not too much, as with anything else in life.
Right. Okay. Up next is Deborah Kurata, Pluralsight author, speaker, Microsoft MVP and a Google GDE. She's also a consultant. And tonight, Deborah's talking about tips and tricks with RxJS.
Okay, are we up?
Yes, we are there. Good evening, Deborah.
Hey. As soon as you started talking, my Google device decided to start talking back to you. I apologize for that. I don't know what she thought you were asking her, but so I had to mute for a minute and try to get her to stop. Okay, so I'm going to talk about reactive programming with RxJS. As he already said, my name is Deborah Kurata. Here I am in one of my favorite places on the planet. And I don't know, are any of the rest of you like super fans like me and know where I am here? Anybody recognize my location? Yes.
I think I've seen this before. I think this is New Zealand, isn't it?
It is. Yes. The Shire. It's actually the Shire. Hobbiton. Okay, anyway, I am a huge fan. I'm going to start with some simple math, or for those in the UK, maths. So I'm hoping you're going to play along with me. So here we go. So X is 5, Y is 3. What is Z? Anybody want to? There we go. Correct. Thank you. Thank you for playing. And there is a point to this, actually. So yes, it's 8. It is 8 for our purposes. Why is that? We'll talk about that well, we know why that is. But what would happen if we then said X equals 7? Now, what is Z? It is still 8, and 8. That is correct. It is still 8. And the reason for that is a value is assigned when the expression is first evaluated. Z does not react to changes in X or Y. But what if we want it to react to changes? What if we want our code to be able to react to those changes? And here's a little example. So we've got an item component here where I can pick whatever I would want. And I want to change the quantity from 1 to, say, 3 of these, because I want to give these to all my friends. I want this to automatically react to that change and update this value. I also want my summary component to automatically update based on what the user changed. So, a thought experiment. What techniques would you use to react to changes in the quantity? So here's my item, my price, my quantity, and the user is going to be able to change the quantity, and I want my extended price to be able to recalculate automatically based on changes in the quantity. Anyone want to guess? Events? Yes, that's a good choice. Anyone else want to throw out an idea? Well, we could do the sometimes hated technique for whatever reason in Angular. People don't like getters, but you could actually do a getter in this case, where I could have a getter for the extended price, and it would recalculate the price and quantity every time change detection determined that the quantity was changed. But the problem with this technique is it would let our item component know, but it has no way to really let our summary component know that it also needs to react to that change. The other option that someone mentioned was to use an event, but this has that same problem. It knows how to react for the one component that where I'm changing that quantity, but it doesn't know how to notify other parts of the application, like our summary component, of that change. So what we're going to try out instead is an observable. Now notice this little thing here in the corner where it says pseudocode. I'm pseudocoding this, and we'll get into the real code in a moment, just to keep this a little bit simpler on the little introductory piece here. So we could then define a quantity, and we're using a $sign on here to indicate that this isn't going to be a variable that's going to act like other variables. It's going to be a reactive variable. And here we are going to move my things out of the screen so I can see. We're going to emit changed values over time with our observable. Then we're going to emit when an action occurs. So when that event occurs, we're going to emit. So here we're emitting into our observable, and it's saying, hey, observable, here's a new value. Lastly, then we can react to those changes. So here, when the quantity is changed, we can pipe through and react to that and define an extended price that automatically will react when the quantity changes. So whenever you change quantity, I'll change the extended price. Now we can take this a little further. This again was from the prior slide. We can also then react to the change in the extended price and recalculate the taxes. Or we can react to the extended price and recalculate a delivery fee. So if it's less than 35 pounds, we charge $5.99. Otherwise, no, how do you say it? £5.99. Something like that. Anyway, yeah. Otherwise it's free. So we can also combine all of these reactive things, and we can define a total price that will change when any of these things change. £5, there we go. So we can change any of these as we go along. So anyone changes, they all get updated. So we can get our total here working. Our subscribers are then notified. So any part of the code that wants to be notified of these changes are these subscribers. And they say, hey, let me know when your value changes. And so it's like, hey, the value changed. This can update its extended price here, the subtotal here, the delivery, the tax, and then our grand total of how much I owe for this space shuttle. All right, so we're talking about two different programming paradigms: an imperative programming style, which is the kind we normally use, where Z is 8 and the value is assigned when the expression is first evaluated, and reactive programming, where Z will emit 8 and then it will emit 10. So it's going to respond and react to changes, and those changes can be propagated as we just saw. So that said, what is reactive programming then? It's a declarative programming paradigm concerned with data streams and the propagation of changes. Okay, reactive programming then involves code code is reactive when an input change leads to an automatic change in output. So I simply change this quantity, or the user does, from 1 to 3, and my output automatically changes to react to that change in the input. Some benefits of reactive programming: we can react to user actions. We can compose data streams, as we saw in our little total example. We can communicate between components. So now, without tightly coupling our item component and our summary component, they are both reacting to the same change. So you can kind of think of that as communicating between those components without tightly coupling them. And we can also manage state. We can keep track of what that quantity is and hold on to it. So where do we get these amazing magical observables? They are part of reactive extensions. Reactive extensions are an implementation of reactive programming principles. They're also a library for composing these observable data streams. Not everyone knows this, but reactive extensions were originally developed by Microsoft as Rx.net. And Microsoft is currently working on a new implementation of reactive extensions that is sort of cloud-ish, and it's called Reactor. So if you're in the Microsoft space and you're interested in that, you can check that out. There are also reactive extensions for Java, Python, and Ruby. And of course, the one that we are all interested in, which is reactive extensions for JavaScript, RxJS. RxJS can be used in Angular, React, Vue, JavaScript, or TypeScript. In Angular, we actually get reactive extensions automatically. So when you use the Angular CLI, it will automatically install the reactive extensions for JavaScript for us. Also, interestingly, there is a ECMAScript proposal for Observable to actually make that part of the JavaScript language. It will be interesting to see if that ever goes anywhere. Okay, so what is an observable actually? You can think of it as a collection of items over time. Unlike an array, which you can also think of as a collection of items, an observable doesn't retain those items by default. So if you just create a normal observable or work with a normal observable, it is not going to retain those items. The emitted items are observed over time. So for example, say I have an array of these letters, and I just left off the quotes just to make this a little easier to read. So I have this array. I could ask you to give me the third element of the array. I could ask you to reverse the array, and you could do all of those things. An observable, though, is like this. There they go. And if I then said, oh, wait, can you give me the third one back? It's like, nope, they're gone. So unless you are going to set up the observable to cache the values or take those values and put them in something else like an array, once those values are emitted, they are gone. Angular creates observables. Routing emits parameters via param map. Form controls emit via value changes. And of course, the one that we are most experienced with, if we do any kind of HTTP, we're going to get that response as an observable. So we've probably worked with gazillions of code that looks like this. We've got our get products method and some kind of service. It's going to return an observable that emits a product array. And that's what this a generic argument is telling you. So we're going to issue the HTTP GET, and it's going to give us back a response. That response is going to be shaped like an array of product items, and then our observable will emit that to any subscribers who subscribe to that. Okay, so now we want to allow the user to add products, but how do we emit into this observable? How do we get more into this? How do we add? How do we delete things? If these are just emissions, how do we do that? And the answer is we don't. Once we get one of these observables from something that Angular is giving to us, it is read-only. We don't have any ability to put anything in to those observables. We can't emit into them. So I guess we just can't do reactive development, and that's the end of my talk. Thank you very much. No, I'm just kidding. So what do we do instead? To declare an observable that we can emit items into over time, we use a subject or behavior subject or another kind of subject. These are the two we're going to talk about. A subject lets us create an observable that we can then emit values into. So you can think of a subject or behavior subject as a special type of observable that is similar to an event emitter. Unlike an event emitter, though, a subject and behavior subject only can emit three kinds of notifications. They can emit a next notification, which then provides you that next emitted value. It can emit an error notification, which then gives you information on that error, or it can emit a complete notification when that subject or behavior subject is complete and can't emit any more items. And that's it. So we can't define our own kinds of notifications like we can with an event emitter. Consumers can then subscribe to receive notifications, and we're all familiar with that process. That's how we get data currently in our Angular apps. So this is what the code looks like for a subject. Here I'm using the private keyword. We'll talk about that in just a second. We're defining the subject equal new subject. This is no longer pseudocode. This is what our real code would look like. And we use our generic argument here to specify the data type of the items that will be emitted. So we're going to emit numbers into this particular stream because our quantity is going to be a number. We're making it private because we have this code in a subject, and I actually color code my little boxes here. The purple ones imply that this code's in a service. You'll see in a minute, little blue boxes are the components and the green boxes are the templates. So here in my service, I want to encapsulate that subject so it's only accessible from the service. That way, no other code can accidentally or on purpose emit anything in or error out my observable. That makes it easier to debug because we know that the only way to get data in has to then be through that same service. But we want the rest of the code to be able to react to the changes in that subject. So we create a second variable with the read-only part, the as observable part of that subject. And that way other code can can subscribe to this and react to its changes without being able to also emit into it. So we expose the read-only part, we keep the part that can be emitted into private. If we instead want to use a behavior subject, the code for that is very similar, except that it has a default value. Now, the key difference between a subject and a behavior subject is a subject looks like what we described an observable to be, where the values are just emitted and gone. A behavior subject is smart enough to cache the last emitted value. So any new subscriber will get that last emission. If there have yet been no emissions, have not yet been any emissions, then it will emit the default, and that's what we're providing here. So a behavior subject requires a default. When anyone subscribes, they immediately get that default value. As soon as it starts emitting, then it will cache that last emitted value and emit that to any new subscribers. Okay, so when do we use a behavior subject versus a subject? We use a behavior subject if we want a default value, if we want newer subscribers to have whatever that last emitted value is. And we also use it if we're going to use any of the combination operators that Angular has. Many of the combination operators won't emit anything until each observable that you're combining emits at least once. And so by using a behavior subject, it will immediately emit, and it will allow our combination operator then to also immediately emit. And we're going to see an example of that in just a second. Okay, so how do we emit? We keep talking about emitting values. Here again, it's purple. So here in my subject, or I'm sorry, here in my service, I can access my subject and I can next to emit that quantity. So I'm going to have a method in my service that any of the code can call, and it then can do validation on the quantity or whatever that it wants to do to provide some controller validation, and then it issues next to issue that next notification along with that quantity. Okay, so let's walk through the steps of how this would work then with that example I started with. So the user selects a quantity. So the user is going to go in and say, I really want 3 of these. The UI is going to generate a selected change event. Hey, the user changed the quantity to 3. That code would look something like this. So this is green. This is my template code. I've got a select on change. I've got a event binding here. It's going to call on selected and pass in the target value. Here I'm just using an ng4 to list my valid quantities. Then in my component, so you can see that one's blue, I'm going to have an on selected that this guy is calling here, and I'm going to get that quantity from the template. I can't in here emit the value because I cannot get access to that private subject. So I instead need to call the service and it will in turn emit the value. Okay, so that was our second step. Our third step is our code responds to the changed event. Our code responding to the changed event emits the new quantity into the observable stream. So the code then says, okay, I saw that the UI changed. I'm going to now emit 3 into the stream. So here again is my onSelected method in my component. It's calling my service. Here again is my behavior subject in my service. It's purple. And here is the quantity change. So my component is calling my service and nexting out that quantity. The code then can react to that emission and propagate the changes. So the code is like, oh, okay, I see that that's changed. I'm going to react and make more changes. So here my extended price is going to react to the change in quantity. The tax is going to react to the change in extended price. The delivery fee is going to react. And then here it's actually real code, not pseudocode. So it's combined latest. And I have all of my values here. Now, again, this will not emit unless each of these guys emit at least once. This won't emit if it was a subject. It's a behavior subject, so it will emit right away. Otherwise, it won't emit until the user changes the quantity. Okay. Any UI or code subscribed to the observable then receives the notification and the emitted value. So the subscribers then receive the notification of this change and can update their values. Now, in these components, they use like an async pipe in order to respond and receive those values. So with that, I have a demo. This is in StackBlitz, so you can run this also. I've got the link on the slide, otherwise you can also see the link here. So I've got a little demo app. So here's my service. I've got a few little hard-coded bits in here. Here is my behavior subject. And here I'm reacting to all of those different changes. And here is my quantity changed method. Now, notice when I pick something here, this data immediately reflects and reacts to that change. If I change behavior subject to a subject, notice that I don't immediately see values in here because it's not doing that initial emission. So it's not able to react to that emission and do any of these calculations. And especially because when you buy something, you assume that they at least want one. I'm going to undo that. You do want it to immediately show what it would be with a quantity of 1. All right, the component then, and this was just a little StackBlitz example, so it's just an app component. I'm getting the values from the service that I can then bind to in the template. Here I'm calling the service to let it know when the quantity changes. And in my component, first I have my quantity. So here's my event binding to the change. And then here I'm binding to the subtotal with an async pipe and the delivery fee, which is not an async pipe because here's the async pipe here. And then here I did it as delivery fee. So that's why there's not an async there. And here is my async pipe for the tax and the total. So that is my little example. And here's the link if you want to screenshot it. Otherwise, I can type it into the notes as well. And so some key points from this section: use a reactive programming approach to make your application more reactive. So the steps were to declare a stream with subject or behavior subject, emit into that stream on an action like click events, a variable change, operation, notification, etc. And then you can react when a value is emitted into the stream. UI or other code subscribes. And again, it's easy to subscribe using an async pipe. And so they will be notified of the omissions. And if any of you are true fans, you might know where we are here on the planet. This is actually called Mount Sunday, but for Middle Earth, this is a different place. I don't know if anyone recognizes it, but thank you so very much for hanging with me for my talk. I appreciate it.
No, thank you, Deborah. It was pretty interesting.
And just a real quick, for those who didn't recognize where this is actually Edoras, home of the horse lords. They had that big golden hall all built up on this hill. They had the funeral here out in the plain here. And then this is where, when they, the Rohirrim, I'm sorry.
That's really good. Is that New Zealand as well still? Or?
Yes, this is New Zealand. This is on the South Island. It's called Mount Sunday. It's somewhere in the middle, sort of west of Christchurch.
Oh, right. Yeah. And so, yeah, if anybody's got any questions, please stick some in the questions.
And that's my daughter with me there.
All right.
We had another Lord of the Rings related question. Was that the Lonely Mountain on your intro slide?
Absolutely, yes.
To
Really important questions.
to go along this line of reasoning, earlier on you mentioned Paramount Plus, so I have to ask Kirk, Picard, Janeway, Archer. How would you? Which is your favorite?
I have always liked Picard, and I thought that was probably the most realistic of actually how management on a ship would work, because, like they never, excuse me, on a real ship, they never send the captain down on the missions. So I really liked Picard.
I was always a captain. Was his Captain Kirk? Was the other one? That was my era. Just a quick question about the and it's something that sort of niggles away at me in the back of my mind. You've got all these, and I know it was just a demo in this case, but you've got these async pipes sort of dotted through the template and stuff. Am I right in thinking that each one of them is a subscription that needs to then sort of I just wonder whether should you have too many of them, or should you just try and sort of get everything into as few of them as possible, so you're not having too many async calls in your template?
Yes, every one of them is a subscription. And one of the things that you can do, and I didn't show it in this little example, but it's at the end of I've got a Pluralsight course on reactive programming. And toward the end of that course, it shows you how to use a combine latest in your component to combine all of the pieces that you want into an object. So then in your template, you can async pipe just once to the object and then dot through it.
Right, okay.
So you would say, dot extended price, dot total, dot, whatever, because you would be binding to an object with each of them defined. Some people refer to that as a view model. So in your component, you would create this view model, which is an object created by combining all of your observables, all your dollar variables into one that's then subscribed with a single subscription.
We have one question there from Yusuf. How do we manage subscriptions when using observable-based services, e.g. a product service calling another observable service like an HTTP?
Excuse me. Personally, I have been trying to move away from any kind of calling. If we go back to the actual definition of reactive programming, it's a declarative programming paradigm. So in my real applications, I've been moving away from calling these services and more into defining them. Let's see, I'm going to wing something here. So here's the course. Here's code from my course, my Pluralsight course. So here's an example where we're doing a VM dollar that we were just talking about a minute ago.
Right.
So we're combining products and product categories, and we're mapping them into an object. And then in the component, or in the template rather, we just have one async pipe. And then when we need to get access to the different parts, oh, I didn't actually change this to use that async pipe. That was not very good of me. We could actually use those. Oh, here I am up here. So I'm using VM products to get access to those. I think I might have something else weird at the bottom there. And then for the categories, the VM categories. So then I don't need async pipes for all of these up here. But going back to the service, so instead of having a get suppliers service or get products service, it's a variable. So it's declarative. So I'm declaring a variable called products dollar instead of having a get products method. And then we don't have to have all of those subscriptions in the component. So then my component would just, it can combine latest with, any of these variables. So here's my category. And here's my categories. For example, I'm just referencing the product category. So it's not having to call anything. And then I can just combine latest on them to display them. And I don't have any subscriptions in here whatsoever to manage. I have no subscriptions because I'm just using an async pipe on my VM, which automatically subscribes to these guys, which in turn automatically subscribes to those. And I just don't have to even worry about subscriptions.
That's really good, that. I keep trying to get to that sort of level. It's just so difficult sometimes.
Yeah, and somebody asked about the VM. Yeah, it's short for view model. So it's the model that we want for our view. So basically what we're doing is we're taking all of our observables and putting them into an object of data. And then by binding to this, it automatically subscribes to that, and we get our data out that we can dot into.
Deborah, do you give courses on how to present? I've explained observables so many times, and never once have I been as clear as this talk.
Oh, thank you so much. I really appreciate that. That is very kind. I've never thought about that, but I would be happy to provide tips or mentoring if anyone is interested in any of that kind of thing. I would be more than happy to help with that.
Well, that'd be really good.
And somebody's asking about failure. So one of the nice things by making it declarative like this, I can individually handle the errors. So I don't have to add a lot of error handling here, because here I'm already taking care of the error handling for this. So this then returns an empty, and I know then that my value here is empty. And my products is just a little bit more complicated because this is handling add operations. and selected category operations. So I'm combining those and reacting every time someone adds a new one or changes what category. If I want to display only the products for a particular category, that's what this code is doing. But I'm able to individually handle errors on the individual streams. And then I can combine them without worrying too much about handling the errors. What are the differences between combine latest and with latest from? I don't use with latest from very often. And I believe that what the key difference is that with latest from only ever emits once. Is that right? And combine latest will keep emitting as these guys are changing. I thought with latest from only emitted one time. Does anybody know for sure?
There's so many operators, it's hard to remember them all.
Yes.
Combine latest is a top level operator. So you combine a bunch of observables together. With latest from is an operator in a pipe. So it only adds data when the observable that you're adding it to emits. So if you want to add extra data when you click a button, you can use with latest from to grab extra data. Combine latest.
Only when the source emits. Yes.
Yep.
You are correct. Yeah, I don't use that one very often, and I forget every once in a while what that one does. But I use combine latest quite often.
Combine latest is the backbone of many applications, I think.
Yes.
Yeah, there was something wrong with latest from, something to the effect of, and I think I wrote it in my course, and I might have to go back and watch the course in order to remind myself, but it seemed like what would happen is if that first stream, the one that you're tying it to, never emitted, or if it finished, that was it. If it finished before the other ones finished, then you wouldn't get what you were expecting. I think it had something to do with that, Lars. Am I right? Yeah, it seemed like it had something to do with the fact that if that one that you were tying the with latest from to finished before the other ones finished, then you wouldn't get what you were expecting. It would just return the first value and not the rest of them. Right. Be aware that combine latest will not emit. Yeah, I mentioned that earlier, that each of the observables need to emit at least once, which is why, like up here, when we're combining them with a behavior subject or with a subject, we use a behavior subject to make sure that it emits at least once. Can you give an explanation between cold and hot observables?
I did.
I had some really nice slides on that, which is what I was going to look for really quick. But basically, the difference between cold and hot observables is that cold. Oh, do you want to explain it, and I'll look for my slide? Were you going to?
I listened to a talk a few weeks ago from Brian Love. And he sort of explained it in the sense that a hot observable was his wife was in the kitchen. His example was that his wife was in the kitchen and she was talking away and he was in another room, but she was still talking away, but he wasn't listening until he actually walked into the kitchen. Then he could sort of do it that way. Whereas a cold observable was that his wife was in the kitchen and she wasn't talking until he came into the kitchen, and then she started talking. Then he could sort of interact with it. So that was his take on hot and cold observables, and that sort of stuck with me a little bit on that, and that sort of helps me sort of understand the difference between hot and cold observables. And it was just sort of a little strange little antidote to it, a sort of antidote to it to help me remember it.
I've stolen an example, and I wish I could remember who to credit for it. but just know this is stolen, and it's going to show my age a bit. But a hot observable is like broadcast TV. It's always going, and you can join it at any time and watch what's going on, but you can't stop it, you can't rewind it, and anything you do won't affect your neighbor's broadcast TV, right? A cold observable is very much like what my daughters think TV is now with streaming services, where they sit down, they say, I want to watch, and they can skip forward, they can rewind, they can do whatever they want to that stream, but it doesn't start until they say, I want to watch this content. And those are the two examples that's what made it click for me.
Yeah, the example that I'm showing here is like if we're using a subject or behavior subject, like that quantity example that we had. If there are no observers, the user can keep changing this quantity and changing this quantity and changing this quantity. It'll just keep emitting items. But over here, if we emit it won't emit any values at all until there's an observer that is there to observe it. So I can run that through again. Where that went. Yeah, so as the user is changing this value, just a little bit more, it just keeps emitting. It won't until an observer, even as an observer shows up, then they'll start getting those values, but it's just going to keep going anyway. And so that is a hot observable. And a cold observable then will not even begin to emit until something subscribes. So here we've got an ABC out there, and it's just not gonna do anything. It's not going to get that data until somebody subscribes. And then the A, B, C, so it's doing 3. But anyway, so that's the slide that I had on it.